Hey everyone, welcome to another observability clinic. I'm here with Mario, and today we're going to be talking about TTP-based threat hunting with Dynatrace Security Analytics and Falco. So before we get into all of that, Mario, who are you and what do you do?
Hi, thanks, Adam. Thanks for having me. I'm with Dynatrace for more than 3 years. I do lots of security research, product-oriented security research, and I really like to catch attackers, like this, also deceive them. That's what I do, and that will be a walkthrough of the blog post that I've written weeks ago. That you can also dive in. It's a brief read, and this is more hands-on.
Yep. Obviously, I'll put links to all of this in the video description below. So yeah, if you want to read the blog post, it's in the description below.
Yeah. So don't worry, I don't bore you with slides, but just want to give you an overview what follows. We will do like a full attacker defender scenario, which is really cool. So we have a demo app that is called Unguard, and I think there will be a session coming up on that. I won't go into too much depth in that. That we have in a modern cloud environment running, in this case AWS EKS, so like a Kubernetes cluster. And I will conduct a novel modern attack in that environment that is composed of multiple steps. And then we will try to find it with Dynatrace and with the help of also some external third-party tools like the Falco, which is part of the CNCF and a free tool to get real-time events. So maybe I would prefer we like really go into the demo already, and I just show you what we are playing with. So we have this app here, and I will start with the attacker side. You already see I have my Kali Linux in a VM here, with lots of attacker tooling inside. We have this Unguard app. It's like a Twitter, or sorry, like an X clone. It's a microblogging platform. So I think I can register myself here, just so that you get a feeling for this app. Alrighty, can log in. Yeah, you see like a feed and some stuff. So it's a normal app. By the way, it's fully open source. You can check it out on GitHub, and it's composed of many microservices. We use it a lot internally for demoing our product as well. So that's cool. And as an attacker, I want to hack it now. So Adam, any idea how an attacker would start on that?
Probably mess around with something they can post, I guess.
Yeah, sure. So I could do that. And there are a few vulnerabilities in there. Just maybe some injection attacks. But what you're also aiming for is like the first step is often like a reconnaissance step. So I want to find out what can I do? What are the endpoints? Can I post something? You see, I have this UI here, and there are tools to automate this process. One of them, one of them is a fuzzer, which is called, like, for example, wfuzz. This is a tool that like sends a lot of requests to the app and checks out what endpoints are available. I won't go into the full detail, but on a high level, what we first need is like something like what an attacker would do. He would download something like a word list. So I briefly show you how that looks like. So this is a word list. You see some common paths like .git, or it goes all the way down to, I think, the /admin /something. So this is a lot of paths that are being tried out on this app, and just to find out, hey, what's what's going on. I think there's also like the oops. I think the REI is also in the sorry, the UI. Yeah. Lots of path. And I can dump this into wfuzz. This is one of the hacker tools that allows me to do this. I will give it my URL. Sorry. And this is like the thing that it tries. So it has the full URL, and then it changes this fuzz parameter to try different things. For Unguard, it's important that it does not break if it gets 4.4. It should follow redirects, and it should exactly use this word list. So you don't see much, but this thing is now trying all the endpoints. It takes maybe up to a minute or so, and I will then directly go into Dynatrace, and we will see what pops up at Dynatrace. So I have, well, yeah, this is, by the way, this is the blog post. I have Dynatrace over here. Okay, it's logging in once more. Yep, so this is the view that you should be familiar with. And the many requests that I just sent, they pop up in the distributed traces. So I can first like manually look at them. I think it takes a minute or so for them to pop up. But if we're lucky, we should see the first ones already. Yeah, you see that we have September 6th. It's early in the morning for me. And this is weird. We have a lot of requests to like all those names. That doesn't look right. This was me. This was the attacker trying a lot of different paths. You also see it now in the terminal. The tool is finished. It tried what it says, 4,700 requests, and it found 2 points. It found the UI, and interestingly, it found like this health endpoint. That's cool. What does that do? Let's check. Looks like a health endpoint. Doesn't really do anything here. Okay.
So just so I'm clear, what we've basically done is just hammer the app with a load of / whatever, and the whatever comes from that list. And basically you've ignored all the 404s, and that tool has found 2 interesting endpoints that you as an attacker might be interested in. Exactly.
And I will go on with the attack, but first I want to show you how you can use Dynatrace to already like create a meta event of that attack that just happened. So I'm here in the notebooks, and I can use DQL to maybe let's say fetch the spaces, the spans, like the traces. Just to get an overview, let's do it in the past 5 minutes. Yep. So lots of traces already in there. You see, like, yeah, Unguard. This is the demo app has been called with many things. I need to filter it down a little bit because I'm only interested in the things that have like an HTTP endpoint and that have a proper host. Maybe try again. And it's still more than 1,000 records. So this is hard to digest as an analyst. So, but we see, yeah, we have this all path. Something is being requested here. And I can show you a trick now. I know that attackers often use like these word lists. They try like 4,000 or 5,000 different parameters. We can look for like to combine all those traces that have that match a few of those well-known words. So I want now to have only spans where endpoint name. This is like the URL path, like this UI health set and so on, where I have like these weird paths, like an attacker tried maybe /.git or /.ssh because the server is misconfigured. Let's see, something pop-ups here. Yeah, great. We have some traces, exactly like one. We have the .ssh. In the blog post, I used like this one. I looked for just the 5 commonly encountered endpoints, and I will just, let's see, add some more code. What I want to do is I want to like aggregate those, in this case, 3 records to have like one meta event that tells me, hey, this was a reconnaissance activity, which is attributed to a certain techniques. I will come to that in a minute, what that is about, because this goes about the TTP stuff. Just bear with me. It's like combining all those alerts to one. Let's do that. Yeah. So I did that, and they have like, hey, on this host, in this container, in this namespace, I found with confidence 0.6, because like only part of the names that I listed here match. I found something that is indicative of a reconnaissance attempts by a hacker. And this is not something, this is a high-level alert that I can easily work with without like digging through thousands of traces. And I think you also saw how fast this was. I did it like 10 minutes, but I can go like 48 hours. I can go days back, and it's equally fast. This was the same alert that I did yesterday in preparing for the session. So it's just super smooth. So maybe a bit of theory. What I just did ties into this TTP stuff. So as an attacker, we started out, we want to learn about the app. We don't want to do reconnaissance. This is a so-called tactic. It's an overall tactic that I do. First, I do reconnaissance. Maybe I try to execute something. Maybe then I try to steal your data. This is an overall tactic. And the way I do this, let's say with my scanner, with my word list scanner, this is then a certain technique. This is one way to do it. As you said, I could just try post stuff. This is another technique. It's more on the how. And then we have one more level. It's called the procedures. This is like the nifty details. Let's say, okay, I tried to access /health set with these params. I executed this and that commands. And often, as a security analyst, you get events for the very low level stuff, for the procedures. You get thousands of them, but this is not what you're interested in. You can hardly work with that. So we want to abstract it up some levels, up to best the tactic level. This is exactly what we did just here. We took those low-level alerts and abstracted it up and said like, hey, this is a reconnaissance technique, and all of them also have then, for example, just the Mitre knowledge base of that, which is a very good one, that also lists, hey, this is like word list scanning. We give it this number. This is what it can do. This is what hackers have done, and so on. So it's a cool taxonomy to work with that kind of data. I already talked about all this multi-step attack thingy. Just to also zoom out a little bit. What we just did was these reconnaissance techniques. I will briefly then walk through a bunch of other attacker steps, like I want to execute code, I want to steal credentials, I want to find other hosts, and so on. This is often called a multi-step attack or a kill chain even, and it aligns to Mitre has this attack matrix. I also like the Mandiant's attack lifecycle model, which is also has like this loop in here, because often when you're inside as an attacker, you start again. You are looking for what's around here. What can I escalate here, and how can I go on here? And this is a cool model to work with, because most attackers kind of have to go through these steps. So
I mean, I'm quiet because I'm learning so much here. It's awesome. But just to summarize, these frameworks are not Dynatrace. They are out there in the world. They're different companies, exactly, different organizations. Yes. So if you're in an enterprise, do you adopt these matrices, or do you just use them to build your own frameworks, or how does it work in practice?
I would recommend you to adopt them, especially the Mitri ones are very common. There is also some specifically for cloud environments or more for enterprise environments. And of course, sometimes you need to still, let's say, write some very domain specific rules, because some Mitri tactics are still on a very high level. It's like saying, hey, there's a brute force attack, but who knows how a brute force attack works with your app?
Yeah.
So I guess, it's a mix. Sometimes if you, let's say, if a Windows environment or common off-the-shelf tools, you have it, but then you still need to do it manually sometimes, or at least gather those rules. So I would suggest we go on with the attack now. So we found this interesting health set endpoint, and as an attacker, I think, okay, let's see, let's dig in further into that, and I will get another word list. This is all public from a cool GitHub repository, sec lists, and this is a word list more with parameter names. So it's like get parameters that you often find. And what I want to do now, I want to dig in deeper on this health endpoint and tell it, hey, I want to like guess the key, that maybe this is a health endpoint that I need to pass some parameter. Maybe I hope some URL because it checks the health of a service, who knows, but I don't know which one. So I do this again, tell it to ignore 500 errors, to follow links. This is again something that we could dig into the notebooks, and it should also take a few seconds because I know there's a vulnerability in there. Maybe in the meantime, while this is loading, I can also tell you we had Falco in the title. So what I'm going to aim next is that we combine the traces that we just digged for with Dynatrace with some like external alarms that we get from Falco. Falco is a project of the Cloud Native Computing Foundation that uses eBPF to to find some let's say attacks possibly, or malicious activity in real time by having some rules in the kernel. So with Falco, I can write rules like, hey, nobody should execute a process here. Nobody should access this file or look into that directory or open a socket here and there. And these rules are enforced in the kernel just for detection. It's not blocking anything. And we take all of that and ingest it into Dynatrace. So also have a small picture that you also find in the blog post with even more detail. This Falco also has this called Falco Sidekick thingy that you can use to like distribute all your Falco alerts to other sources, one of them being Dynatrace. And let me get this straight, you need this platform like Dynatrace to really work with those alarms. Otherwise, it's very hard. We will see. We will also briefly dive into that.
So if I again just summarize this so that I understand it, you've got your one agent deployed, which is all of the infrastructure monitoring, but all of really the kind of in this scenario, it's the open telemetry traces. It's the distributed traces, right? It's that kind of level that we've been looking at so far.
And even more, it's everything that one agent delivers you. It is also injects like into Java processes and does even more, but yes.
So then you've got Falco using eBPF looking at the kernel level. It's just another layer of defense, another sort of eye, another lens sending events. But you've got all of that data. You've got the traces and the events now. And that's why you said you need a system like Dynatrace to kind of bring order to this massive amount of data that you've got.
Exactly. And Falco is quite noisy, as we will see. You need so you need such a tool like that. So let's see. The fuzzer is done by now, and the fuzzer found. Well, we could have guessed that the key of the get parameter is just path. Okay, so I can probably go like path. Let's say dynatrace.com. Okay, and it tells me healthy. That's interesting. So it looks like we found an endpoint where we can enter arbitrary URLs and check if they are live or not. Let's see, can I do localhost? Okay, I can do localhost, but who knows? So that's interesting. We're already like a little bit closer to finding this weird endpoints in this Unguard app. I could go on manually and like check test out what I can enter here. Maybe there's some buffer overflows, maybe some command injection vulnerabilities. There's also tools for that, which are just like enter here. This is like one another tool is commix, which checks for command injection vulnerabilities, which you can simply like give this endpoint and tell it, hey, exploit the path parameters, assume this is a Unix system, and it then will go on and try like to really get command injection vulnerability here that eventually gives me full full code execution. And this is kind of the part of the demo. I know that this is possible, but an attacker could easily do that. This also takes a while, and it's very sophisticated check. So if you're into that kind of stuff, check out their docs how they do it. It's super cool, and it's all automated. But I already have like like an exploit script that I found together with commix, which I can tell. Just one moment. Which I can like tell, hey, this is the victim address. And I found a way to execute Perl scripts on that via a command injection vulnerability that commix will find in a minute. And this command will then open a reverse shell to that host and that port. Adam, do you know what a reverse shell is, or should I briefly explain that? Getting very hackerish here.
No, go for it.
Yeah, so a reverse shell is then like on this endpoint, it will connect to this host and this IP. So this is owned by me, by the attacker. And it gives me a full shell on whatever pod or container this health thing is running, because commix found something. Just need to give it some more time, and there's some very crazy stuff over here. So, but in the meantime, I would just say that we try this out already. And briefly, I will need yet another terminal, because I need to be on this very host here. Just give me a second or so. Okay, that's good. So I have like what attackers often call a CNC server, like an emulate one. This is an attacker-controlled server where I just get a shell here. Assume this is somewhere in the internet. I know this is like the IP address of that server. It's the 10.178.4890. And I now, let's see, I will now on this, where is it? Yeah. On this attacker machine, I will now listen for open connections on port 1337. And
so
now
you're now waiting. So you're on
yes,
your machine, your command and control server here.
Exactly.
This is something
that's
owned
mine
by you.
Yes.
What commix and what the other word lists have done is basically hammer against Unguard, automatically found a vulnerability. You've then written that in this Python script that we see to exploit that, and that reverse shell is basically going to give us that shell as if it was our server. So
exactly,
as soon as that starts running, you're going to see the CNC server pop up and say, "Oh, we're connected," and then you're inside. You're inside.
Then I'm inside.
Yeah.
Yes.
Wow.
So let's see if the demo guys are with me. So run the exploit. Yep. And you see, I've already a shell here. So I have a full shell. Okay, I'm envoy. Looks like we're in the proxy, in the envoy proxy. So we are not root here, but we have a user. Okay, now I have a shell here on Unguard. So I'm in one pod, I'm inside a Kubernetes cluster. So this is already locked. What should we do next, Adam? Any ideas?
Burn the world. I don't know.
Burn the world. Yeah, you can do that. You can burn it to the ground.
Maybe a bit more subtle than that. Yeah.
As an attacker, like what is often done is like I would look for tokens in your file system. Actually, there are none hardly here, or like some SSH keys, so some data that I can steal. Looks like I don't have permission to look into everything, but so this is one thing that I could do. I would install some attacker tooling, but okay, I cannot apt-get update. But what I can do is like from inside, I want to scan the network. I want to know what's behind the envoy proxy. And there's also sadly I don't have IP, like IP to check my IP address, but there are different ways to find that. And what is our IP address? Come on. Yeah. So like this is the IP address of the envoy thingy. And then I could like go and download just the binary for Nmap. Nmap is a tool to scan the network. Give it executable permissions. We can zoom in a little bit on that. We will mostly be here anyways. And then I can go, let's say, this is our network. Let's scan the network and let's see what pops up. Okay, interesting. Does this look familiar to you, Adam?
It looks like
we have like EC2 internal, like ActiveGate. Okay, there's like Dynatrace in there. So we are in a Kubernetes cluster. We are in an AWS Kubernetes cluster. And the first thing that I would try here is like to connect to the Kubernetes API. So maybe let's try kubectl get nodes. Okay. Sadly, this won't work because in newer versions of Kubernetes, you don't get the service token automated, but otherwise this would already be very catastrophe. So one more reason why you should do role-based access control. and don't give your Envoy proxy full permissions to the API. But you see, I'm just fiddling around here. And we are close to like the last step, which is I know if I would scan the network, I would see we have a Redis server in there, and I know that Redis does not require any authentication, so it could just like go to Redis and like tell it, whoops, sorry, I need to execute executable permissions. Go to Redis and tell me, hey, what's your config? And here it is. That's the Redis server of Unguard. And maybe this info thing is not the most interesting one, but oops, I just disconnected, sorry. Let's do it once more, hopefully. Okay, I'm not sure if it will connect the second time, but I'm already done as an attacker here. I could connect to Redis, and instead of sending info, I send it keys, and I fetch all your data. And now, as an attacker, like I'm done. I get all your data. Maybe one last step would be to also cover my traces. Maybe let's try a different port. I would really like to show you that. And actually, this is not, I don't blame the demo guys. As an attacker, you encounter many of these situations. The tools are like barely working. Let's see. Oh yeah, okay. A different port did the trick. So as an attacker, one thing that I would do, like I want them clear the bash history so that the analysts won't, okay, there's actually none in here. That the analysts won't find any traces here. I could also like clear some logs and so on. And this is what I wanted to show. I can do like get all the keys of Unguard. Oops, wrong directory, sorry. And this is all the data from the Redis. So now I'm done. And now we are going, unless you have questions that we're going to briefly like analyze it with Dynatrace.
No, I think just summarize. I mean, I'm blown away, but the point I want to make is that it's futile if your application's on the internet, whether it's deliberately vulnerable. Hopefully it's not. Obviously you haven't made it deliberately vulnerable, but you know, it doesn't have to be Unguard a vulnerable application. You're going to be getting hammered from everywhere all the time, 24/7. You can't stop that. You can try, but if they're persistent enough, this is gonna happen. You might not get reverse shells, but you're gonna get, you know, your systems are gonna get prodded. So yeah,
it's just a matter of time. If I just dig hard enough, I will find something.
Yeah.
Okay. So let's go more into the defender mode, and this will be fun and quick. So bear with me. I told you we ingested Falco. So let's look at what we got during the, let's say, last 30 minutes. And hope you see how cool that is with the autocomplete as well here. So Falco events, come on. Oops, I will make this big. Okay, I have it got trimmed. Maybe let's change the visualization briefly. Oops, I like this one. Yeah. Maybe just briefly look at how many have we got in the last 30 minutes. 4,900. That's what I meant with Falco is noisy. So, I mean, I can tell you, I should have done this even before the attack. Falco is like generating like 5,000 or 10,000 events anytime, and somewhere in there is like the needle with all those attacker steps that we just did. So this is the challenge, and you need a proper tool to work with that data. Maybe let's check one abstraction step. Let's check what techniques we saw Like, I'm not interested in all those nifty details. I want to do, let's see, a donut chart. Sadly, it has no description here, but this is one way that one thing that I can do. Like, I can abstract it away to the overall techniques. So we have a picture. Okay, this is like, let's see, in 39% is the T108. What is that? Okay, file and directory discovery somehow. So I know where most of the events are. I can tell you, and I will not go into also too many details on that, we have a few false positives in here because this app is very broken and it accesses environment variables in a very insecure way, which generates a lot of noise in itself. But I can easily filter them away. So I looked at just 4 to get rid of them and get a clearer picture of what is going on. But still, this is a little bit fragile to work with. So one more thing that we can do, and I will pop in the query and then explain it. And it's really cool. So I take the same data. So this is just the data that I just visualized. I have all these events, I think, on abstracted to the techniques, like this was reconnaissance. You saw we accessed credentials, we accelerated data, and so on. So this is somewhere in those categories. What I want to know now is I want to group all of that data by, let's say, the Kubernetes pod. And this is a field that we have. You can only do that because this field is readily available in all your data in Dynatrace. And per Kubernetes pod, I want just like to count how many unique tactics and techniques did you see there. Maybe this is a crucial step. Like we have all those procedures, this like the small events. We extract it away, and my I assume I have it here. I want to see like, hey, is there a pod somewhere where we see some reconnaissance activity, some code execution stuff, some credential access, and so on, because then we know this is where we need to focus on. And I just run this query I need a table. And look at that. It tells me, maybe this helps now. It tells me now, hey, in your Envoy proxy, I saw 5 events that can be attributed to 5 techniques happening. And this is very suspicious because it looks like an attacker did at least 5 different steps here. So let's maybe drill down on that part. So once again, I will fetch the logs. What did we have the last 30 minutes? We have Falco here. Sorry, I just copied that. Falco, yeah. And I will just filter on that pod name that seems like this is not the noisiest pod. This is not the pod with the most events. It's just the pod with the most techniques. That's the crucial thing here. And let's give me some more fields. Sorted by timestamp. And now you see the magic. Look at that, Adam. So these are the steps that we did. I showed you this exploit script. We have it in here. Falco found, hey, someone redirected standard in, standard out, exposed it to a network container. Hey, someone looked for private keys or passwords. Someone tried to update. Someone did a network scan. Someone tried to execute, get the Kubernetes API. Someone again did connect to the Redis. Someone tried to remove the history. So these are the procedures. These are like the nifty details. But we only found it the first, like abstracting it away to those techniques. And this, I think this is really cool.
This will be extremely, just to clarify as well, we haven't, so what you're looking at here, MITRE.technique, you know, the output fields proc command line, the event.name, this is all coming from the one agent and or Falco. So
yes,
all of the once the data gets into the platform, it doesn't really matter where it's come from. You can mix and match this data to fit how you need to see the world. But this is going to be excellent for a defender, of course, but to actually see, hopefully you never get compromised. But if you do, you've got the history here. You can go back and see exactly what happened when, you know, and where it happened. That's really powerful.
Exactly. And I mean, the crucial thing that any defender that probably listens in knows is like, I want to make you aware, like we did this, but like we did this, we picked the needle out of this 8,000 alerts. And this is just a cluster with this one app. If you have like a full production cluster, you have easily like really 100K of events. So you need those. It's really cool to have those steps and then first abstract, drill down again.
So you've gone, what you're saying, if I've got you right, is you've gone from 8,500 events to 14 records that gives you exactly, literally exactly what you typed into the command.
Yes.
Wow.
Yeah. That's like, do we have one more slide? Nope. That's like the story. I have one more picture if you want to pause here and dig into it. This is like steps that we did. This is an architecture diagram of Unguard that as an attacker I would not have. But you can check it out. You can also play around with this environment if you need it for anything. And this is like the steps that we did. We scanned for the endpoints. We found those in the traces. This is one thing that I have to say, this is currently missing in this list because it was not available yet in Dynatrace. It is now. Maybe we do an updated blog post so that you can easily also add that data. So it's definitely possible. Then we discovered this health set endpoint. We used a tool to have command execution there. We opened this reverse shell. From that, like, we expanded into the inner network, did a network scan, discovered Redis, exfiltrated the data. And then we catched it all again with ease, I would say.
And do you have a sort of a slide or something about the defender kind of workflow?
I would really direct you to the blog post because this goes in depth on, let's see, you have all the queries that I just run interactively.
Oh, fantastic.
You see this diagram here. You see the strategy that we did with finding the word list-based scanners. And what you just said, what we just saw, the final techniques. So the blog post was more on the defender side. So and this video is like the hidden, what happened behind the scenes.
That's fantastic. It's just, it's absolutely fantastic. It really, really, there's so much to digest there, especially coming from an observability background as I do. It's quite scary that people can do this on your infrastructure, but it's pretty good that we've got the tooling there available to help stop and help give you the observability of it being attempted, shall we say. Hopefully you never get exploited. But Mario, unless there's anything else, thank you so much for your time. I've really enjoyed it. It's been good fun.
Great to hear.
Great. Catch you next time. See ya.
See ya. Bye.